Okay, Wildcat 7.4. Keeping it real, rewriting radical expressions. Warm up. Extract roots to rewrite each radical expression. Alright, so we can rewrite the square root of 48 as a square root of 3 times 16. Which we can rewrite then as the square root of 3 times the square root of 16. Which the square root of 16 is 4, so that's the square root of 3 times 4, which let's rewrite that with the number in front as 4 square roots of 3. All right, let's take a look at number 2. So we can rewrite the square root of 27 as the square root of 3 times 9, which we can rewrite that as the square root of 3 times the square root of 9, which equals the square root of 3 times 3, which, let's go ahead and put the 3 in front, so that's 3 square roots of 3. All right, so here we can rewrite the square root of 32 as the square root of 2 times 16, which can be rewritten as the square root of 2 times the square root of 16, which can be written as the square root of 2 times 4, which, putting that in the front, is written 4 square roots of 2. All right, go ahead and finish up the warm-up. All right, let's take a look at getting started. The power of positivity. You know how to use the properties of power to rewrite expressions. 1. Simplify each expression. Okay, so A. So if there's not an exponent, we put a 1. When you multiply exponents, we add them. So this becomes A to the 3 plus 1, which equals A to the 4th. Now, when you divide exponents, you subtract. So this becomes A to the 3 minus 7, which equals A to the negative 4th. Okay. When you multiply exponents, you add them. So this becomes A to the 4 minus 4, which equals A to the 0 power, which anything to the 0 power is 1. Now, squared means that there's 2 of these. So this becomes A, B times A, B squared. Which means we have 2 A's, we have 2 B's, 2 B's. So that's A squared, B to the 4th. Okay, A squared, that's A squared times A squared, which is A times A, which is 1, 2, 3, 4, so A to the 4th. Now, anything divided by itself is 1. And let's mark that out. But also we know that when you divide by a fraction, you subtract. So that's A to the 6 minus 6, which equals A to the 0 power, which equals 1. Now here, when you have an exponent on the outside, you multiply. So this becomes A to the 8 divided by 2 times b to the 4 divided by 2, which equals a to the 4th b squared. You multiply exponents, you add them, so this becomes a to the 4th. Well, but they're different letters, so really it stays the same. There's nothing you can do. It just stays a to the 4th b squared. All right, go ahead and finish those up. Go ahead and mark out the rest of the page. Let's take a look at the next page. 4.1, extracting variables from radicals. Previously, you've rewritten radicals by extracting roots involving numbers. In this lesson, you will explore how to extract roots for expressions of the form n to the x n to determine how to extract a variable from a radical. Let's consider several different values of n. 1. For each value of n, for the expression m to the x to the n power, analyze the table and graphs, identify the function family associated with the graph, and write the corresponding equation. So this corresponds to this graph. And the function family of the graph is the absolute value equation, and the equation of the graph is y equals the square root of x. All right, let's take a look at the next page. Okay, this corresponds to this graph. And the function family of the graph is the linear equation, and the equation of the graph is y equals x. Okay, this corresponds to this graph. And the function family of the graph is the absolute value equation. The equation of the graph is y equals absolute value of x. All right. This table corresponds to this graph. And the function family of the graph is a linear equation. The equation of the graph is y equals x. And then go ahead and mark out E. All right, let's take a look at the next page. Go ahead and mark out this page. Rewriting radicals as powers. In a previous course, you have learned how to rewrite a radical power with a rational exponent. And to rewrite a power with a rational exponent as a radical, you can use the rules of exponents to verify the relationship between the powers and roots. All right, go ahead and look over the worked example. One. Why is the restriction given x greater than or equal to 0 stated at the beginning of the worked example? The restriction given x greater than or equal to 0 was stated at the beginning of the worked example to ensure a real number value for a square root of x. For x values less than 0, the value of square root of x is imaginary, not real. 2. How do you know when the initial x value can be any real number, or when the initial x value should be restricted to a subset of the real numbers? Restrictions are placed on x values if they are undefined in the original expression. All right, let's take a look at the next page. The student works 3a, 3b, and 4. All right, go ahead and start working on your assignment, and have a wonderful Wildcat day.